Yo, what's up, everybody? Welcome back. Today we are working on our video game, and today's topic is trying to do any form of animation system. This is our idea for a game. We've done a little mock-up in Blender. My thought was I need to decide if the kind of like overall structure of the game will work, and to do that I need to see it like visually in some way. So we did a little bit of a Blender mock-up. Last stream it didn't look anything like this. The kind of like vibe, the idea was there, but we hadn't figured out the right vibes. But off stream we got there. So the idea is that we're going to make like kind of like a couch co-op real-time strategy game, right? So the idea is that like you're sitting at your TV, you've got your controller in your hand, and you are trying to build an army to fight your friends, right? So here are two armies, one of them is purple, one of them is pink, and the kind of flow of the game is that you kind of spawn in like the corner of the screen or something. You spawn somewhere, you have like a couple guys. They collect some berries, right? Tasty berries, and their whole purpose in life is to feed berries to their giant slug monster, right? So here's their little guy. When they feed the giant slug monster a berry, you know, he eats, they need to feed him enough berries. Maybe you like, we're gonna juice them, turn them into liquid or something, but whatever. He's gonna be fed, and after he eats some berries, he is going to shit out another one of these guys, right? So he's not only our giant slug monster overlord, but he's also our mom. Imagine that these like paths don't exist yet, right? Like it's all cut off. We have like, I can't cover on my screen. It doesn't like fix what you guys see, but like imagine like we're only here, right? And then we run out of berries. So with these guys, they'll run over here and they'll start like cutting down some trees, right? They'll cut down some trees and like maybe we'll work our way over to the next set of berries, right? And eventually we will like create some sort of like environment for us to fight in, as well as like pathing to get to the next berries, and we'll run into like our other army, right? And the way like the fighting is going to work is like these guys are really fucking stupid, right? All they're going to do is they're just going to like sprint towards some drone that's flying around in the air, right? And like you as like the user are going to be like controlling the drone, maybe two drones, right? Maybe you'll like split your groups, your guys into like two sets. But then when they like collide with the other group, they'll just start like killing each other, right? And then there's going to be like dead bodies, and we're going to be like, well, what if we just fed our monster overlord the dead bodies of our foes? So we'll like carry, you know, this guy, like he gets in his arms, and we like walk him back, walk him back over, you know, to our guy. We feed him to the guy now, and then we get more men on our side. And then eventually we'll have eaten all of the people from the other team, and it's kind of like a numbers game / also like you're going to be trying to like coerce your guys into attacking from the back, probably. So if they like fight head to head, they're going to be kind of like 50-50 on who wins. But if we attack from the side or from the back, then we have like an advantage. And so the game is going to be like, you're going to be like trying to like move your mobs around to try to fight and like eat each other from the backs, essentially. That's the game. We have this. This is all we have right now. And we do have like this animation for this guy that we were playing with, right? They kind of run around, wee, right? Look at them, look at him go. And so we want to try to, you know, run this animation on our guy, which means that we have to figure out how the fuck to do that at all. So that's the plan for today, is to try to like maybe extract try to figure out if we can like, how is this animation represented? That is something that we don't really know yet. And so we know that there's like some stuff in the GLTF file that we've exported from Blender that we're importing from our game. We're probably going to try to like make some bones, put them at the right spot, then probably do rotations. If we somehow manage to do all of this very quickly, we can start like deforming mesh according to bones. But I suspect that we are not going to make it this far. So I think we're just going to like jump in and see where we end up. 0415. Okay, so we have some exported file that we are loading in here, right? That's how we've got this guy here. He's not fully loaded, but he's somewhat loaded. And maybe we can look for the word animations in this import file and just see what it looks like. So it looks like we have this field called channels. Channels has samplers and targets. So he is kind of saying node 16 is we are going to adjust the translation of this node, would be my assumption here. So I'm assuming that you're going to look at animation sampler 0, right? And we're saying like sampler 0 has effects on some bone somewhere, right? So if we were like to go back into Blender, and we go back and look at this guy. Hold on, let's try to find the right view into this. So we have like our character, and in here, can we visualize the armature? Question mark. Here, right? So we have these bones, right, that move like this. So it looks to me like we have node 16 is probably one of our bones. It's hard to get indexes in here, but we know that bone 1 is index 1, so they're not in order. But we can probably assume. We can assume that we're one of these bones. Each of these bones has like a parent, maybe, as well as a rotation, scale, and translation. Okay. And so we can assume that the animations are affecting these guys. So our samplers are input 59, output 60, input 61, output 62, interpolation step. So this is interesting. These must be indexes into something. Somewhere there must be some like rotation or translation data. And yeah, these must go somewhere. So maybe we look at the like, well, if our first goal is to render the bones, it seems likely to me that we don't have to think about the animation yet, right? We only have to think about the bones, which have like initial positions, right? So maybe we start here. Now the question I have is, how do we know that the node is a bone? Right? We can go off the name bone, but I think that's like just like an exported name from Blender. Like, how do we tell the difference between nodes that are meshes? Okay, well, mesh says mesh in it, which is a pretty good clue. But this stuff doesn't say like I am a part of some armature. Maybe the top level armature does though. Maybe the armature in our scene graph, we have kind of like the top level node, which is node 0, which is an empty. Does not seem promising. Does not seem that promising. I guess maybe the fact that the bone is part of an animation might be a bit of a clue, right? So maybe we look at the animations. Oh, wait, armature. Wait, this is promising as well. Armature sounds very interesting. So he has children 21, but he doesn't even say, like, he's not like typed in any way. It just says armature. And the armature, I guess, from Blender's perspective, is like this. I think we didn't have all the names correct yet. Can we export this again and just see if the names change at all? I think that will help me. Include active collection is probably what we want. And is he GLTF separate? And can we go to untitled? Okay. Yeah, okay. So this is character now. Let's just make sure that this still loads. It does, except it seems that we have accidentally... I think last time we probably exported this with applied transforms, would be my guess as to why it looks different now. Data... Right? It would have had to be. Mesh, apply modifiers. Maybe... Did we have like... Huh. I'm not sure. This is definitely not the way it was before though, which is not good. Not good at all. Oops. Yeah, why is this different? Let's just also double check that if I what would we have done? Export. GLTF. Scene graph. No. Mesh. Apply modifiers. Material. Armature. Oh, maybe we changed the origins of things by mistake. We might have. If we like... No, see, his like origin is over here, and that's probably how it always was. Is there like apply transforms as part of this? Transform Y up. I don't really see anything that looks like that to me. Apply modifiers is like the closest thing that I've seen so far. But maybe we just don't worry about it. Huh. Interesting. Untitled GLTF. All right. It's a little annoying. We could also... Yeah, it's so weird. It's so weird. Okay, I guess for now, what we'll do is we will... Can we just select this and call apply all transforms? No, we can't. Okay. Well, that sucks. That sucks, but we can... We can at least try to filter for bones. Let's just go back to trying to render the bones, and we'll think about this later. We know, I mean, the fact that all of these guys have their origins at 0, 0 is like kind of reasonable, right? Because in the GLTF, we have like locations set for everything, including the bones, but like if we look at like left eye, right? This guy has a like rotation, scale, and translation. We're not applying those things. So it would be weird for it to be correct, which it was before. That's weird, right? So we must have done something funky when we were exporting last time, and I'm not going to think too hard about it. Okay, let's go back to trying to figure out how we like determine which of these things are bones. Right? So we have the name bone. Armature, is that like a thing in here? We have armature action. Let's maybe look at the GLTF spec and see if that gives us any clues. So can we look at like bones? Animations. Okay. Note. GLTF does not specifically define how an animation will be used when imported, but as best practice is recommended that each animation is self-contained as an action. For example, walk and run, blah, blah, blah. Contain multiple channels, targeting various bones. Okay. So this is an example of an animation. So we have a name, we have some channels. Channels connect the output values of a keyframe animation to a specific node in the hierarchy. A channel's sampler property contains the index of one of the samplers present. The target property is an object that identifies which node to animate using its node property, and which property of the node to animate using path. Non-animated properties must keep their values during animation. Okay. What about like texture data, materials, scenes, nodes, and hierarchy? A node may have some transformations, blah, blah, blah. Okay, maybe this is too much. Too much reading. What if we ask the idiot? We ask the idiot. He might have an answer for us. In GLTF, how do I know if a node is a bone? Question mark. That's all I want to know. If a node has a skin property defined, then it represents a bone. Do we have that? Ooh. We do. So this is, no, I mean, this is just a lie. This skin property, this is a lie because this thing is not a bone. This is not a bone. So I don't know why it thinks that. Okay, if the node has a joint property defined, so that's not it either. Right, our bones are like, this is what our bone looks like. Hierarchical structure where each bone node has blah, blah, blah. Yeah, it seems like a fucking lie. But what is the skin property? Can we maybe... Skins. Skins are stored in the skins array of the asset. Each skin is defined by required joints property. Okay. Oh. This looks promising. So this skin is applied to the mesh. The mesh. Let's see. Skin. There's only one skin here. And I'm fairly confident that the animation is supposed to apply to like the sword and shield as well. So that's kind of weird. But this joints thing does look kind of interesting. So each skin is defined by required joints property that lists the indices of nodes, uses joints to pose the skin, and an inverse bind matrix property that points to an accessor with inverse bind matrices data used to bring coordinates being skinned into the same space as each joint. Okay, interesting. The order of joints is defined by the skin joints array and must match the order of inverse bind matrices accessor elements. Okay, so it looks like there's some like direct way to go from like object space to bone space for each bone, I guess, or maybe only for the root. No, this is an index into something. So this matrix, this is going to have like some binary data that has like a bunch of matrices for each joint, I assume. The skeleton property, if present, points to a node that is the common root of the joints hierarchy. So we don't have that anywhere. So this has must have floating point components of mat4 type. The number of elements in the accessor referenced by this must be greater than or equal to the number of joint elements. Right. Joint hierarchy is used for controlling skinned mesh pose, is simply the node hierarchy with each node designated as a joint by a reference. Each skin's joints must have a common parent node called common root, which may or may not be a joint itself. Okay. So I guess let's start here. This seems a little reasonable to me. Right, so we have, at the very least, a list of joints. Now, I don't really know... Okay, so we have like, also interesting here, we only have nodes 24 now. This is like, we have one node in our entire scene at the root, which is our character, which is this guy. And he has children 23 and 22, which means he has like the body and the root of the armature. So we know kind of externally that this is the root of the armature, and we know that he's indexed 20, 24, 23, 22. Which is the root of this guy. Okay, yeah, that looks promising. Looks promising. So let's go into our main and try to load bones, I guess. So let's say try to load some bones. So can we maybe on our export here, we will add some bones? Question mark? For now. I don't think that this is really like correct, but we'll just kind of make it work. So for now, let's just say that we have a bone that lives at some location. translation. Yeah, we can kind of start there. And then we'll figure out rotation and stuff later. Okay. So in order to load bones, we're going to go over skins, I believe is what we said it was called. Okay, and yeah, in skins, he has, we need to like write the parsing part for that. So we're going to be like, you might have a skins field, and it's going to be a bunch of skins. Simple. Now that means that we need to define what a skin looks like. And we know that it has joints is the only thing we care about right now. Joints. And I guess we default initialize this to an empty slice in case there's nothing there. Okay. And now we should be able to for each joint, we should be able to be like, let's make some output bones. Uh-huh. So here we're like, out bones, append, nodes at the joint index, translation, I guess. Yeah. Translation is equal to this, and then translation is in vec3, so we need to do a little conversion here probably. So it's like, translation is this. Let's just call it tx. And then we can say tx0, 1, 2. All right. Now we need to parse this part, so our like node needs to have like translation as an optional. Right? And then here we have to check, or else continue probably. Sure. Okay, and then at the end here we have like bones is out bones, bing, bang, boom. And now we should be able to like iterate these things in some way. Probably. So somewhere we should be like, we need to copy this stuff out of the scratch space. Okay. And I guess our render loop right now is going to be like, let's not even bother rendering the model anymore. Let's do for bones. Why does he think he's materials? Because, yeah, it's confusing. This should be a bone. Yeah, it is. Okay. So can we render something bone buff at some location? So we need like translation is going to be model like world transform, I guess, is going to be a 3D transform translation at bone translation 0. We just do this a few times, I guess. And then we do its world transform followed by the viewport transform. Uh-huh, that sounds like kind of right. And now we just need like something to render there. So can we just like make a bone? let's let's just get a little fun here. And let's make ourselves a little bone. So can we, what does like a bone look like? He's got like something like this. We probably want to like cut it here and then extrude this and this. And then like separate them a little bit. I don't know, man. Yeah, something like this. Hmm. The fuck does a bone look like? Bone. Here we go. This. Yeah. So it's like, give me this, and then this, and then these guys kind of like bridge down into something. So like, I don't know, man. Something like this. Something like this. I don't know what I'm doing. Then presumably we can like join some faces together here to get something reasonable. Like if we're just like, whoa, you know, get close together, sirs. And then we're like, merge by distance. And we just pick a distance that kind of snaps these guys together. Hell yeah, dude. That's close. I think it's like, are we boning right now? Yeah, we're boning so hard because we just, this is like not relevant to the problem we're trying to solve in any way, shape, or form. This is just because I think it's fun. Like, it feels like this crease needs to be like way farther up, you know? Like maybe even like all of this stuff just kind of like, maybe we like do the same like merge shit over here. Where we like merge all this stuff together. Oh yeah, that maybe looks kind of bone-like. A little bit. Kind of all of this needs to just be like smaller. Sure. That's enough like a bone, I think. Who cares? This is like so stupid. It does not fucking matter. Does not matter, but I can't help myself. I love you and nobody else. Bum 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 bum. Mirror. Do dun 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 dun. The Z0. Why is this not mirroring the way I want it to? Probably because these faces need to be deleted. There we go. That's a bone if I've ever fucking seen one, guys. Guys. You don't think that looks like a bone? I think that looks like a fucking bone. I think you guys are crazy if you think it doesn't. Saved it, yeah, with the mirror, I guess, huh? Oh, there's another fucking inside face there. Not that it fucking matters. There we go. Okay. Save. Bone blend. Okay. Do we need to make it the right color? That's about right. Do we need a shade smooth? Oh, yeah, dude. Okay. Okay. So now we need to probably export this bone as something that we can use here. Okay, and then somewhere we probably want to like, actually let's just build and see where that gets us. My dog would love it, hell yeah. Oh, right, we don't compile right now because we never finished. But we do now have bone GLTF, which is pipe. We should now be able to bone model is from zig out share bone asset GLTF, I think is what we called it. Yeah. Okay, and then we say like bone buff is make GPU buffers of root render alloc. What else does he want? He wants the loaded mesh, which is the bone model, and he wants the bone program. So that's kind of this, and we just kind of do this down here somewhere. Bone buffs plural, and then we can render these things. So for bone buffs, bone buff, boom, bang, bang, boom. All right. All right. He's mad because bone buffs, I didn't write try. He's mad that model buffs is unused now. True. He's mad that materials is unused as well. So can we go back here and just be like, model buffs and materials. Get that shit used so that he doesn't get mad. Promising. Those bones are like mega big. So we should maybe shrink these bad boys down. Apply scale, I guess, probably. Maybe. Maybe? Something about that does not feel right to me. So if we were to look at like the armature of this guy. All right. Dude, you're being so annoying. You're being so annoying. I'm just gonna time you out. You don't have to fucking like just like post your how many seconds you have left in your left in your ad all the fucking time. That's like so fucking annoying. Okay. Can we look at our little guy? Look at our little guy. And which guy we exported this one? I think they're the same. They're just different color, but you know, theoretically. And can we look at like where the bones are in the armature? Why don't I see anything? Can we, okay. So this is where I expect the bones to be. I expect like maybe 3 in his legs, 2 in his torso, and 4 on each arm. Which just like is not what we are seeing here at all, right? Like there are so many just like fucking centered. Like so many. So I guess maybe I wonder if their like locations are relative to their parent. Probably, right? So would that make sense? Let's pretend that everybody is offset from their parent. So some of them are offset horizontally a little bit. So these two bones here could be his like top leg bones, right? Then we might have like two bones here that are his like two shin bones. Maybe are for like these 2 feet could be these 2 bones, maybe like a little offset forwards. Maybe. Yeah, I think that we probably have to apply their parent transformations. That's going to be my guess. So let's just try that and see if that gets us anywhere. We could also check spec, huh? Translation in the example below. So this is joint hierarchy. That's node 3 and node 4 are ignored because they are not part of the skin. Sure, but like reading the manual like a total beta. Sure. Okay. Nodes translation along the X, Y, and Z axes. Okay. Nodes and hierarchy. Nodes may have transform properties as described later. Nodes are organized in parent-child hierarchy, known as a node hierarchy. Of course, a node is called a root node when it does not have a parent. Node hierarchy must be a set of disjoint strict trees. It must, so it's acyclic. Sure. Node hierarchy is defined using a node's children property. Node name card has 4 children. Each of these in turn could have its own children, creating hierarchy. Transformations. Okay, so we may define a local space transform either by supplying a matrix property or these guys, right? Known as TERs. Translation and scale are 3D vectors in the local coordinate system. Rotation is a unit quaternion value in the local coordinate system where W is a scalar. Nice. Okay, so that'll be useful for later. When a node is targeted for animation, only TRS properties may be present. Matrix must not be present. Okay, cool. To compose local transformation matrix, TRS properties must be converted into matrices and post-multiplied in the TRS order of, okay. Global transformation matrix of a node is a product of the global transformation matrix of its parent's node and its own local transformation matrix. That's what we were looking for, baby. When the node has no parent node, its global transformation matrix is identical to its local transformation matrix. Sure. So we just have to walk the fucking tree. Is kind of the way this seems like it's working. And then probably we actually are going to have to apply its rotation as well, right? Because if you have like, wait, which way is it? Product of the global transformation of its parent node and its own local matrix. So I assume that like you're gonna have like, you know, something like this, right? Some like thing, and he's gonna like, maybe he's gonna be like rotated. So now he's like this way, and if our second bone, our like child of this guy, says like take this guy and go like up in this direction, so our next guy is maybe gonna look like this, right? That means that after this rotation, it's gonna be like this, right? Because we're gonna like follow the first arrow, go forwards in that amount, and then rotate down. Which means that in order for us to correctly model this like bone system, like we're going to have to apply the rotations, I think. But if we don't apply the rotations, what we should probably expect to see from this is like, I think that our little like pelvis is our root bone. So I think we should have like this guy here, then this guy, and then his arms relative to their parents should have like reasonable translations, right? So then we should end up with like a bone here and a bone here. And then since these guys are all kind of like in the same direction as each other, we should end up seeing the arms as like arrows going up, right? If we didn't apply any rotations. And then the legs should be like the first leg here and the second leg here, and then there's like shin bones that go along the axis of the bones, and then a foot. So if we got this right, we should end up seeing a bone system that looks kind of like this. I think. So we can try that. We can try that. And then once we get this, then we can start trying to apply rotations as well. Sure. So we almost certainly are going to want to preserve the hierarchy in some way, right? So it also said in the spec that children have exactly one parent. So there's no like sim links or anything to worry about. So can we call this like armature? And he's going to have a collection of bones, right? And each bone is going to have a bone index. We could even get like kind of crazy and have bone IDs like this. Okay. Now, how do we get the transform of a bone? So this is like local translation is what they called it in the GLTF spec, or like the local transformation. And so I guess this is also optional, right? He might not have a parent. Here, maybe we have a, like invalid. Right? We can kind of do this. Which lets us not have to like add an extra byte to track that. We can just do this now. We need this to be kind of like this, I guess. Okay. Cool. So now what? um So this is going to give us some sort of transform, right? And we're going to get the transform for some bone ID, right? That seems kind of reasonable. Probably. And so he's going to say, get me the transform of my parent. Probably. So we're going to be like, bone is self bones at ID. If ID value is equal to bone ID invalid value, we have a problem. So we're just going to hit unreachable. I guess maybe this is an assert play. I guess that will become apparent very quickly though, because we're going to try to index into this thing and then it'll crash because ID value is out of bounds. So that's fine. If what? If bone parent. Oops. We do p self transform p then bone local translation. So we have like bone transform is going to be a transform 3D translation from bone. This is, yeah, bone local translation 0, 1, and 2. Okay, nice. Then we run parent, then transform. Otherwise, we return just the local transform. Okay, that seems kind of reasonable. So we kind of like walk up our hierarchy and we just keep going for our parent. Now, I think this might go the wrong way. Because it feels like we're like walking the whole parent hierarchy like for each layer. It feels like by writing it this way, we've done something where we have like, you know, A, B, C, D, and we're going like, okay, compute this guy's transform, and to compute his transform, he computes this guy's transform, and to compute his, he computes this guy's. No, that's fine. That's fine. That's one per. We're chilling. We're chilling. Okay. So now what? We need to like construct this parent hierarchy in some way, which means that like when we load the GLTF, we must have to like load from the like we have to like load the hierarchy here. You know? Kind of feels like this instead of whatever the fuck we were doing here, which means that like our I guess probably our output bones, we're still going to have like a list of bone IDs here. I think that makes sense. Now these bone IDs we're going to have to like convert from node IDs. Probably, right? Because like in the GLTF, they have like the bones are just nodes. And we're kind of saying like, no, 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 no. Not all nodes. Just the bones. So our bone IDs are going to be like different. So we're gonna have some sort of like map in here. Bone map is going to go like from node ID to bone ID. Right? Like something like this. And probably like, can we in it with like some capacity? Probably. Just to try to avoid like wasting too much space from like heating up. Probably. Okay. So out bones. I think this is fine. So now when we look at each of our bones, we're going to be like, have we looked at this one already? Because here we have to like recurse down all of his children now, I think. Right? So like each joint is going to go to some node. Right? And like here we're gonna be like, let me check my children because I have to. Yeah, I have to like look at them. So this has to be something recursive is probably the easiest way to do this. So we're gonna be like, maybe having some sort of like bone builder, like armature builder makes sense here. And he is going to have like this stuff in him, probably. You know, something like this. Sure. Uh-huh, 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 uh-huh. Yeah, something like this. Bones. Bum 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 bum. Okay. This is like bones and ID map, I guess is a better name for this. We have like bones is bones and ID map is ID map. Okay. So now we probably also want in this builder, we're going to want like a reference to the GLTF data. Right, surely. So here we probably take this guy in. And then we can do like push bone. Can we just look at like node ID? Sure, that sounds right. Right, that sounds kind of right. And he's gonna do whatever we were doing before, kind of this stuff. Armature builder like this. We're gonna be like self GLTF nodes. We're gonna look at the node ID like this. We're gonna check if we have the node ID. So we're gonna do like self ID map gop with this ID. If gop found existing, we have nothing to do, right? We've already looked at this bad boy. Okay. Now what? Now what? I guess we should check if it has a translation first. Okay, so if this thing doesn't have a translation, but he still has children, we might want to look at that in some way. But for now, let's just say, okay, we don't have children. So we're going to look at the nodes. We're going to, if we don't have a translation, we're going to like ditch that shit. Then we're going to try to like look the map. If we find it, we're going to say that the node ID is equal to something. Probably this. Okay. That seems reasonable. Now, we have to track children somehow. Right? So we're going to go like for each of our children. Node. We don't have children yet. But we are going to. And we're going to, I guess, call like append with the child node ID. And this is going to give us back the bone ID. Yes. And then we can say like self bones at bone ID parent is equal to bone ID or to node ID. That sounds kind of right. So this will like set all of the parents. That sounds kind of right. Yeah. Yeah. That sounds like it might work. So now we have like a bone builder is bum 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 or armature builder. Uh-huh. Yes, 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 yes. This is going somewhere. For each joint, we say armature builder append joint. Uh-huh. No function named append, because I need to write try on init. True. Need to write try on append. True. This guy's mad because there's no field name translations. This is local translation now. True. And now we need to add children to our GLTF loader. So each node has like some children, which is going to be a list of use sizes that's kind of empty by default. Okay. Outbones here is no longer our guy. This is get the fuck out of here. And now this is going to be like armature is armature builder build. Okay. Cool. This thing needs to return a bone ID, and we need to return gop value pointer like this. All right. That feels pretty good to me. This thing needs to... Maybe this is an optional bone ID. So this can return null if we don't have a translation. I don't really know what to do there. Or... Yeah, we need to do something there. So here we need to be like, or else continue, I guess. Expected bone ID found U size. True. True. We should be using the bone ID here. Good thing that we strong typed that shit. Good thing that we strong typed that shit. Okay. So now we don't give a fuck on that side, I think. And now we need to build the armature. So how the fuck do we do that? Surely this is going to return an armature, and he's going to take in our self as an armature builder. And what's he going to do? It's just like... Probably something like this. Bones is like self bones make contiguous with your allocator. Sure. Yeah, that seems reasonable. Sure. What's he pissed about? This thing can fail. True. True. Okay, and then now, like, this thing, he's going to have... Probably we want to put him on the right allocator here, which is kind of silly, but whatever. Whatever. Okay. Yep. All right. Cool. Sure. That should do it. Okay, so now at 8:53, when we're trying to use these bones, it's like different now. So do we want like a root of the armature? Yeah, here is where maybe it feels like we're double iterating again. Right, we're going over all the bones and walking the parents all the way up, which is kind of silly, but it's whatever. It's whatever. Okay. So this is, we need some sort of iterator, which is going to return a iter. So this guy needs to be like, we're going to give you back a bone ID when you call next on me. And I guess we're just going to have like max is a U size. Index is a U size. This is maybe a little silly, but it's fine. Index is 0, max is self bones len, bang bang boom. If index is greater than or equal to max, return null. Otherwise, return a strong type like this and defer index plus equals 1. Boom, 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 boom. Simple, simple, simple. Okay. So now we should be able to iterate our bone IDs. While bone iterator next, we have bone ID, and now we extract that from the armature. So we say bones transform at bone ID. Cool. And so maybe that compiles and works now? Fuck! 92. So if bone parent is not equal to invalid, I guess like is valid is a better way of doing this. Which means that our bone ID needs like is valid bool takes in like ID of a bone ID and returns ID value is invalid dot value. Not equals is better here. Okay, so that kind of fixes that. And then 96 is like if bone parent is valid, we have now bone parent like this. Chill. And then somewhere, surely we, oh yeah, it's auto initialized to invalid. Hell yeah. That's really good. So if we look at what we drew in paint, we lost it. But this is exactly what we predicted, which is a really good sign, right? We were looking at this guy and we were saying, okay, so there are parents on these bones, right? And we think that this is the root, this guy here. Boom. Right? And then we're saying that we're not applying rotation, but transformations of these guys are like transformation stack. We're not doing rotations, we're only doing translations, right? So this guy sits on top, boom, set of 2, right? Then we have these guys over here. So the first one is like over here somewhere, but then because of all these guys are kind of pointing in the same direction, they kind of stay stacking on top this way. So we should have a set of 4 over here. We should have another set of 4 over here for the other arm. And then his leggies, we should have sets of 3, and because they're rotated 180, the first one will be in the right position kind of here, but then we'll have like a set of 3 like this. One for the shin and the foot, and then here, shin, foot, like this. This is kind of like the conversion of this armature if we don't apply rotations. And if we look at this, this is like what we got, right? So we have 1, 2, 3, 4. 1, 2, 3, 4, which is his 2 arms. Then we have his like his tummy, 1, 2, and then his leggies. 1, 2, 3, 1, 2, 3. So that's really good. That's really good. It means that we understand this at least a little bit. So I would say that we have probably gotten into try to load some bones. I think we like understand the format, but now we're kind of falling over because we don't support rotations in any way. So we need to support bone rotations. I think that's kind of the next step. Okay, so that means that we have to like parse some quaternions, which, lucky for us, is why we built this visualizer on the left here. The idea behind this guy was to try to help us to understand quaternions. They're like these like 4-dimensional things that represent like an axis angle, and we were gonna see like as we like compose them and stuff, like if we can like gain some intuition about how they work. So I think that's probably the first step here, is to try to use quaternions in some way. Maybe we don't actually have to understand them right now. If we can just use a formula to convert quaternions into rotation matrices, right? Because we don't actually have to work in Quaternion space, I think, until we're trying to interpolate rotations. We're not trying to interpolate rotations right now. We're just trying to take some fixed rotation and like put it somewhere. Where Quaternions, if I understand them correctly, start to become really useful is as you if you're like, I want to go from here to here, like you can very like easily do like a spherical lerp on those guys, and like just because of the way the math works out, it like ends up looking like a smooth, nice rotation. That's my understanding. It's very, very coarse, which means that we should be, yeah, but we're not doing that. So in our case, we should just be able to be like quaternion to rotation matrix. I guess technically this is the same thing as axis angle to rotation matrix. I think I've seen something called like Rodriguez formula for this in the past. Comparison with other representations of rotations. How do we see like quaternion derived rotation matrix? Let's go, baby. Okay, so here they have here IJK is like so my understanding of quaternion at this point in time is that you have some vector that's like in the 3D unit sphere, right? Kind of. It's kind of a lie. Okay, imagine you have some vector in the 3D unit sphere, right? So this can point kind of anywhere, right? Like our little visualizer here, right? This arrow is like the 3 out of the 4 parameters. He's always length 1, right? But he's pointing in some direction. Then you have like basically like how much are you rotating around this vector? That's my understanding, right? So if you point it up this way, any rotations are going to kind of go around like this, right? So if you point them this way, they're going to go around the x-axis. So something that's like on the z-axis here will go kind of like whoop up to y, down to negative z, down to negative y, back up to y. If you point it up to y, it will go like x. Oops, it'll go like x to z to negative x to negative z, right? That's my understanding. And then it's kind of like the ratio of how much is in the imaginary component of this number, i.e. like the IJK part, versus like the real component is like how much the rotation there is. But even that we don't really have to fully understand. We just have to understand which of these 4 parameters are IJK and which one is the real component, because in the GLTF spec, when it was talking about rotations in here, it said somewhere which parameter was supposed to be the real one. So angles determined direction. It's kind of like it's probably easier to just show in Blender. New general. So like say we have like this cube up in the air, right? If I were to like rotate this cube around the around like the x-axis, this is like the amount of rotation is the angle, and which way we're rotating is based off the arrow, right? So this would be like you have an arrow that's kind of pointing like along this red axis, right? If you were to have an arrow that pointed along the green axis, it would rotate this way. So like the magnitude is like how much you're rotating, and like the direction of the arrow is like where you're rotating around. W is the scalar. So here it's probably XYZ are IJK, and W is the real component. So here that means that QR is W. So probably the easiest way to do this for us would be, let's in our bone add in a rotation. Local rotation, and this we're going to represent as a quaternion, which does not exist yet, but it's a good idea to stub this out for later, because we're going to be doing more stuff with this later, I'm confident. So this is going to have like probably like 4 F32s, and here we'll just say like real like RIJK. we'll just kind of write that down so that we know in the future how this is getting stored. Maybe it makes more sense to store this as R. Like this. I, J, K. Right? And in reality, probably us storing this as XYZ might make more sense. But it, like the handedness of this coordinate system seems important. Like in this, they are kind of referring to, they've got a right-handed coordinate system. X, Y, Z. Yeah, right-handed coordinate system. And Z is going up, which is not what we want. So we should call this like X, Y, Z here, and we'll say relative to this, X equals I, Y is equal to K, and Z is equal to Y is negative K, I think, in this world. And Z is J, I think. Because we'll say that, like, picture on Wikipedia is Z up right-handed. We use Y up left-handed, I think. Let's just check that. Left, right hand coordinates. Yeah, we use left hand, and then theirs is right hand. Yeah. Yep. I believe Y is J. I don't know. I think in their scenario, yes. Yes, I agree. But I think that we have a different coordinate system from them. Right? So like their Y is like horizontal to the right. Our Y is vertical and up. Right? So it just kind of like makes shit kind of confusing. But I'm pretty sure that this is the way. So then when we go through this, where was there like matrix representation? Rotation matrix. Where were we? We're Quaternion derived rotation matrix. Here we go. Okay. 2 transform 3D. Okay. So this is going to Jesus Christ. This seems like the type of thing that the idiot is good at, to be honest. Can you make me some Zig code to convert a quaternion with fields R, X, Y, Z to a 4x4 matrix, or row major matrix, represented as 16 F32s. Question mark. If we're deciding on representation, some people put the real part last in the W coordinate because then the swizzle quad XYZ makes more sense. Probably doing it the way GLTF does it is a smart choice. I don't know what that is. Swizzle quad XYZ. Oh, just in terms of like layout and memory? Yeah, it sounds kind of right. Okay, is this kind of close? Does this look... Do we think that he wrote the right thing here? That's the question. So we have 1 minus 2 times y plus z times z. So that's jk. What is s here? Where is s coming from? S is absolute value. Oh, sure. So if it's a unit quaternion, which it is, sure. So he's got that part right. 1 minus 2s, and then he's got 2 times ijkr. IJKR. Yep. Then 2 times IKJR. IKJR. Yeah, that seems right. 2 times ijkr again. Oh, it was ik before. Now it's ijkr. Sure. ijkr, I agree. 1 minus 2 times I squared k squared. 2 times yz minus xr. 2 times yz minus xr. Chill. I think he's got it right. We should need to be careful. So 2 times xz minus yr. 2 times xz minus yr. Hype. 2 times yz plus xr. Yz plus xr, and then x squared y squared. 1 minus x squared y squared. Yep, okay, cool. So this is, about right. Now we just have to fix our labels here. So we were saying that, okay, let's replace this with I, this with J, and this with K. No. Yes. Yes. Okay, IJK. And then we need to do the conversion from our components to their components, right? So we said that their Rx is their I, their Y is our Ry is their negative K. So this should be negative Q dot Y here. And then their J is our Z. I think that's right. I mean, that's like, we're getting real sketch here, but that's fine. How do we represent this thing? It's just called inner, probably inner data. Okay. Oh, what the fuck? Where am I smoking? Holy shit, I just started changing some random fucking code, dude. Alright. That looks kind of right to me. That looks right to me. And then we'll say, who generated this? Claude, my friend Claude, wrote this kinda, and we cross-referenced with Wikipedia. Smiley face. Okay, cool. I wonder if this was faster than me writing it by myself. It felt like it was, but maybe it wasn't. Because we did have to just check every single value anyways, but I feel like the chance of me copy pasting my brain wrong is higher than the chance of Claude copy pasting his brain wrong. But who fucking knows? Okay, so now we have these quaternions, and we just have to like specify these local rotations. So we know that there's like a no rotation, like identity for a quaternion is no rotation around the axis. So we know that this should be r equals 1, x equals 0, y equals 0, z equals 0. Which is kind of nice. So we can just say here now, somewhere, we can use identity if it doesn't exist. So we can say like Rx is no rotation or else identity. And then we need so this is going to be represented as R is node rotation 3. And then they had XYZ as the first 3 parameters, I believe. But then we probably have to do some like left-hand to right-hand conversion here for this to make sense. So we'll just say like left hand. Like, they're, which one are they? Are they right-handed or left-handed? I'm assuming here. Rotation of the unit quaternion vector. I'm pretty sure. I mean, we had the same problem here where no, they're Y up. We have a GLTF of Y up, but right-handed. Fuck. So that means we just invert X, I think. I think everything else is the same. I think it's like this. We're really kind of flying by the seat of our pants here. But this is what we did for like translations and stuff. So that feels kind of right. Left hand. So there. GLTF is right-handed, Y up. We are left-handed, Y up, so flip X. I think we're getting really out here. All right. Unused local constant, Rx. True. Local rotation is Rx. Okay, and I guess this is if node rotation. Yeah, it's like this. Const Rx is if node rotation. We do all of this stuff. Otherwise, we're identity. Expected optional type found quaternion. What's the problem? Okay, I guess he needed a little. No, what the fuck? I don't understand the problem here. I feel like this should compile. Am I high? Oh, else here. Not or else. Aha, there we go. Okay. So that means this probably auto-resolves, and here we need to write pub on identity. Okay. Expected this. Okay, and then we do need to... I lied. This does need to be... Oh, even then. The auto-resolution maybe doesn't make it through. Oh, maybe I have to do this. Maybe. There we go. Okay, so now this parses, but we have to actually do the work here. So when we try to construct our transform, we have our rotation. So this is, which order did they say we have to do it in? Rotation, then translation, of course. That makes way more sense. Yeah. So it's like bone, local rotation, to transform to 3D, then do this. That's something. That's definitely close, right? So we can tell that his arm bones here are rotated in some way. The translation is getting applied in the wrong order, maybe? Maybe? Or we've just done something like brain dead wrong, right? Yeah, that doesn't seem to fix it either. Okay. So now we have to start trying to debug a little bit better, I think. All right, so this is what it looked like before. Then we huck. Okay, so I guess what we should do is we test our Quaternion uh, representation, right? So we can take a bone and we'll just put a bone at 0, 0, then rotate him according to our little unit vector shit, and see if it behaves in the way we expect, and that'll help us bisect if the problem is in our like quaternion to matrix math, or if it's in our like our interpretation of how the rotations are represented in the GLTF, or stacking of compositions. Right? There's all sorts of things that we could have got wrong here. Yeah. So let's see. Okay. So how do we want to do this? We have this widget here that is explicitly made for this, right? So maybe we start when you apply the local transformation to the when you apply the local transformation to the parent is already rotated. It should be, yes, should be. Yeah, which I think lines up because like our parents are like bones. Oh wait, it's not there anymore. Hold on, we lost it. We lost it. Here we do like bone to transform 3D, then do the translation. Right, like the fact that all of the arm bones are like rotated by approximately the same amount lines up with my understanding of how this should look. Right? Just kind of hand wavy lines up. Then they're like, it's like their translations are on the wrong axis or something, which doesn't really feel right, but whatever. I mean, maybe, are we doing like parent then child wrong? Are we supposed to do bone transform then the parent? Am I stupid? Oh, that's actually way more promising. Wait, that actually looks kind of right. I think. It's hard to tell. Hard to tell. No, because I don't see any feet rotated the right way. I feel like somewhere we should see feet coming out forwards. Well, this does seem at least kinda close. Great visualization of the bones. Oh, I guess also the bone, his coordinate space is wrong. Here, this should probably be something that's like, it should probably be more like this. And then what is our like vertex position here? Z 0.9, so should probably be like a little bit bigger, something like this. Let's see if that changes anything. And then probably their scales also probably matter. Let's see, untitled GLTF. So their scales are all very small, so surely these are relevant. Surely. So let's try applying those as well and see how that changes anything. So wherever our bones are, local scale, this is just probably a vec3 here. Okay, and then wherever we apply local rotation, we probably need to do like, I don't know where this X came from, but we're gonna keep using it. Okay, so we have here, it's gonna be like probably S0, S1, and S2. Otherwise, if this thing doesn't exist, he's probably going to be something that's like 111, right? Something like this. Why is he mad about this? Probably it's like this. Nice. Okay, and then we need node scale. I feel like this, there's some syntax error here. I can't find it. Oh, here. There we go. Okay, so now we need node scale. Which is 3 F32s. Okay. We say local scale is SX for some fucking reason. You can select the bottom vertices and then do 3D cursor to selected, then an object mode origin to 3D cursor, so the pivot where you want it to be. Yeah, true. True, you can do that. I don't know. I'm sure there's a reason you're saying that to me. I just don't remember what it would have been. Okay. So here it's scale, then rotation. So const scale is, one of these guys. Boom, local scale 0, like this. Boom, 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 1, 2. We have then rotation. I guess we can kind of do it like this. We do translation is the rest of this shit. Then we can do the transform is like scale, then rotation, then translation. Let's see if that looks kind of good. I do not feel like it does. Okay, yeah, okay, this doesn't feel right. I mean, they're like, we're definitely seeing something. Did we set the, like, we did save this, right? Can we visualize a bone just like with identity transform? Let's try that. And then once we visualize a bone with identity transform, we can start playing with the Quaternion stuff and seeing if that's right. That feels like the play. So we should be able to be like, ditch all this shit for a second, and let's just render a bone with identity transform. Boom, 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 boom. Okay. Sure. That looks about right. Not quite. Hide the bones. Hide your bones. All right. Yeah, okay. So this is correct, right? Our bone is approximately 1 unit tall, sitting at this location. Okay, cool. So let's try rotating this guy with some Quaternions. So Quat is gonna be like, we have some unit dir, nice. So what is it? It's like you have some angle, and the real component is like the cosine of that angle over 2. So it's like rotation amount over 2. SX is the other way, sine. Right? And then it's like Quaternion is the real is cosine x. X is sine x times unit dir x. Y is times y, and z is times z. So we should be able to just take this thing. Can't you just try to rotate according to your compass? That's exactly what I'm trying to do here. That's exactly what I'm about to do. So that's what this unit dir and rotation amount are coming from. These are coming from the compass. And then here we should be able to be like transform, or like world transform is quat to transform 3D. We apply that here. And then we just need this to be a quaternion. Which he's not liking for some reason. Quaternion. All right. Okay, so let's just see stupid like. So that's a good sign. We do see that like we are seeing what is a sane rotation to some extent, right? Now, what I'm not liking is that I feel like he's rotating over the wrong axis. So if we rotate him over the x-axis, that's correct. Now, I'm a little bit worried about the direction of rotation here. So if we rotate over the x-axis here, as we increase our rotation value, he's rotating clockwise, which I feel like is wrong. I don't know. Okay, we rotate over the z-axis. Is the z-axis... Okay, so we have a mistake here. It looks like we shouldn't have changed our axes. Probably. Probably. Maybe we got a little confused here. Let's try keeping the math with the correct axes. Because I guess maybe the axes like propagate in some way. Okay, so still clockwise around x. What about z? Clockwise around z as well. Okay, what about y? Clockwise around y. Okay, so now this is consistent, which is good. And then if we do over some like combination of these things, like, you know, about like 50 x around xyz, here we're rotating over like the axis that is going into the camera right now, which I would say is in fact happening. Yeah, that's super fucking hype, dude. Okay, cool. So I got confused here. I guess it's that I thought that because their axes were different, ours should be as well. But I guess like it's our axes propagate all the way to the end. So why would it be? I'm not 100% on the clockwise versus counterclockwise rotation. I feel like clockwise is unexpected. Yeah, that doesn't. I like everything in my brain says that it should be counterclockwise. Right? Because like when you have an XY plot, your angle goes this way, right? Typically. So I'm a little concerned there, but let's go back to trying to render the bones as the as they are in our GLTF and see if they make a little bit more sense now. Oh, let's fucking go, dude. That's a lot closer. Look, we got his little feet down here. See his little feet? His arms are... I worry that they're rotating in the wrong direction. This is almost certainly not right? Because we're going on his like his right arm is pointing to the left. They're like pointing. It's like they've like inverted like this, right? Oops, sorry, I just punched you guys. Which makes me think that maybe that like X inversion that we did for like left hand to right hand coordinate systems maybe is wrong. So I wouldn't have thought that it is, but let's see if that changes anything. Yeah, there we go. That's like way more correct. So why is that? Because we definitely flipped like the model in X before. Oh, maybe we have to flip the translation and the rotation, and we didn't do that. Yeah. We need to flip this as well. That's why. And we can check that by making sure we can change the bones. No. What the fuck? Why does this have no effect? Confusing. Something in here feels wrong. Oh, it's that the translation. Also, I'm concerned about like bone sizes here. The bone scales don't seem to be changing, which is kind of strange to me. But maybe we're supposed to like maybe that's not part of it. Might not be. Okay, let's try turning one of his hands so that we can kind of understand like which hand is supposed to be his left and right, so it's not like perfectly symmetrical. So can we go to like our character here? And can we go in here and let's look at the bones? Like this. And can we go into edit mode on this guy and just do something like silly like this? Hello. There we go. Okay, let's export this. Bump, bump, bump. Bump, 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 bump. Okay. Confusing. That's actually super confusing. I feel like we should see some change there. Unless we exported the wrong thing. File, export, GLTF, include active collection, go to untitled GLTF, which is this. Okay, here we go. Here we go. Yeah, see, so what we're seeing here is that it's his right arm when we fucked up his left arm here, right? So negative translation seems right to me. Right? So now... Why is this not doing anything? Like, this should have an effect. Right? Am I fucking high? Right, if I set this to 0, surely then... Oh, I guess this is X. That's confusing. That's... Oh, I guess it could be that he's facing backwards. It could be that we need to invert Z here, but then why... No. Okay, can we turn off rotations again real quick? Can we just do identity here for a second? While we try to understand this. Okay, so with no rotations, this is what we look like. Which makes sense. Now, can we like also just kind of move his right arm just like like this. So his left arm should be like way forward and way to his left. I shouldn't have saved that. That's annoying. That was a dumb ass maneuver, but it is what it is. I don't think that there's anything that we wanted to save in here, so we're kind of chill. Okay, so his left hand should be way over to the side and way forward. Here, it's his right hand, right? So that makes me think that we need to invert something. Oh wait, did that do it? Yeah, so now it's his left hand. Now it's his left hand. Nice. Nice. Okay, okay. So now this is correct. So now I guess we bring the rotation back in. Bring the rotations back. And it's like they're rotating. Okay, can we go back? Undo rotation, undo rotation. We need to look at which axis is which. Which axis is which? So here he's facing negative x, which maybe that's kind of weird. But sure, so he's facing negative x in this world, right? We bring the rotations back. And which way does it look like he's facing now? Looks like he's facing positive x now. Which makes me think that all rotations over like one of these axes are backwards. And it makes me feel like it's the z-axis. But I don't think that's right either. Yeah, I'm not sure. Could be that like let's think about this. We need to think. So we have x, y, z. They have x, y, z. Right? So it's kind of like our x-axis or our z-axis are inverted from each other. Which I guess kind of means that like, okay, so if we were to rotate counterclockwise around x, that means that initially you get smaller z, which in this case we would get bigger z, right? So that's a problem. If we were to rotate counterclockwise around z, we start with bigger x. So all of these are backwards. If we start rotating counterclockwise around y, oh no, wait. Yeah, we start rotating counterclockwise around y, we go from positive z to positive x. Here we would go positive x to positive z. So it feels like around every axis, we just have the wrong rotation direction. Doesn't Blender have z up, y forward? But in the export from Blender, in the export here, it's y up by default. So it seems like you can change like which axis is the forward axis and stuff, but you can't really change like the handedness. So looking at these three examples, it feels like we just invert the rotation. Which means that we invert all three axes, question mark? That doesn't sound right. Yeah, that's definitely not right. Definitely not right. Okay, there's something funky going on here. I have to think about it a little harder. I think just trying it over, isn't that just conjugate? Yeah, I think I did something fucking stupid there. I need to think about this a little more. But I'm pretty sure it's like related to this. At the very least, we have something that's like quite close, right? If we just don't do any inversion, we have something that resembles our armature, right? It's just got some like wrong-handedness, right? This does resemble this. It's just mirrored, right? And so we have to figure that out a little bit, but I'll have to figure that out. Swapping the imaginary axis sign changes the rotation direction. Yeah, that's what I thought. But I mean, I'm doing something wrong. I just have to think about it. It's fine. But I think that this is a success. I think that this means that we have like an understanding at the very least of the like armature format in the GLTF, and we just have like a little bit of math shit to figure out. So pretty hype. Pretty hype. I think we call it there. I think we will try to implement deforming a mesh according to these rules tomorrow. So if you want to see that, swing back by around tomorrow at 2 Pacific time. We stream most days at 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now, so 3.5 hours ago to now is when you should expect to see us live. We split the stream into 2 segments. Typically, there's like the 12:30 to 2 segment, which we call happy hour, which is like less structured, things that I don't really think that I can make like a YouTube title and thumbnail out of is basically like the metric there. Where the 2 to 4 segment is kind of what you're seeing now, where we have like a very like strict, like we're going to do this set of actions now, which we often fuck up, but we at least try to have some sort of like agenda. So if you want to keep up, there's the 2 to 4 segment gets posted on YouTube. The 12:32 segment, you have to catch it live or join on Patreon, sub on Twitch, or join on YouTube. All 3 of those will give you access to VODs of the 12:32 segment. But if you catch it live at 12:32 Pacific on Twitch, you don't have to pay. Please consider supporting. If you want to see this content continue, it will end someday, right? This is way less lucrative than working a normal job, right? Like way less, like 20 times less, maybe even less than that. I have to look at the numbers again, but so eventually I have to go back, but every dollar I make delays that a little bit longer, right? So consider supporting if you want the content to continue, but otherwise, no problem at all. I think that's it. YouTube, peace out, and Twitch, let's find someone to raid.